Okay, let's dive right into this explainer. Today, we're going to reverse engineer how a system called Resonate solves what is arguably one of the absolute hardest problems in generative AI right now. And that is maintaining deep contextual relevance without ever falling victim to hallucination. We're looking at a context engine designed to place verified, licensed text, in a specific case scripture, directly inside the AI conversations people are already having. But honestly, the underlying architecture is what's truly groundbreaking here. We're going to see exactly how an AI knows when to speak, what to say, and how it mathematically guarantees it isn't just making things up.
Here's our roadmap for the breakdown. We'll start by defining the hallucination problem, then look at the architecture's division of labor. After that, we'll go deep inside the data pipeline, break down the hybrid retrieval and fusion algorithms, examine their deterministic safety gate, and finally wrap up with how this all gets deployed in the real world.
So, kicking things off with part 1, the AI hallucination problem. Every single day, billions of people type their most raw, honest emotions in the chatbots. We're talking about grief, burnout, doubt, fear, real human stuff. And traditionally, the tech world has given us two pretty flawed solutions for injecting trusted knowledge into those vulnerable moments. On one side, you have a separate app, but that inherently breaks the user's context, right? Nobody wants to pause a deep, vulnerable conversation just to go open another tab and search for a resource. It completely ruins the flow. On the flip side, you have a standard generative AI bot. Because it relies on probabilistic generation, it frequently hallucinates wording, it spams the user at the completely wrong times, and honestly, most dangerously, it can respond to a genuine human crisis with a cheerful quote instead of actual help. Resonate is engineered to be the missing middle between those two extremes.
Moving on to part 2, let's look at the architecture and the division of labor.
To actually solve this problem, Resonate introduces a massive structural paradigm shift. They call it anti-hallucination by construction. Instead of crossing your fingers and probabilistically hoping for accuracy by tweaking a prompt, correct behavior is structurally guaranteed by the code itself. The language model is completely stripped of the capability to generate source text. It is literally never permitted to write the reference material. It's an entirely different way to think about AI safety.
The secret sauce here is a strict division of labor. Think of it like a highly specialized assembly line. On the left side, you have Gloo AI Studio handling the language understanding. It reads the emotion, segments the emotional beats, and writes a tiny one-sentence connective bridge. In the middle, you have the custom Python engine doing the heavy algorithmic lifting, the matching, memory management, and deterministic safety checks. And finally, on the right, the YouVersion Platform API acts as the absolute sole source of truth. It supplies the exact, licensed words based on a strict USFM plain text format. So the LLM only ever outputs a JSON reference code. It acts as an indexer, not a writer. Because the model can't generate the text, it is structurally impossible for it to hallucinate the text. Genius, right?
Okay, part 3. Let's actually pop the hood and look inside the data pipeline. Let's trace the journey of a single, messy HTTP request through this 10-stage pipeline. The raw text first hits a hard safety gate in stage 0. If it detects a crisis, it stops everything immediately. No AI, just a hard stop. If it's clear, stage 1 uses the LLM to segment the user's message into emotional beats. It identifies the theme, the emotion, and assigns an intensity score from 0 to 1, which actually gets amplified by gravity cues like words associated with mourning or loss. Stage 2 is a vocabulary check that strictly enforces restraint. Because honest silence is always better than a confident mismatch, the system will abstain entirely if the theme is unknown. From there, stages 3 and 4 kick in, running an advanced hybrid retrieval and fusion process to rank the corpus and find the absolute perfect reference.
Continuing down that same pipeline, stage 5 takes those candidates and rescores them using a per-user memory graph, meaning it accounts for what you've talked about recently and checks the tone fit. Stage 6 is a confidence check, and this is crucial. If the margin between the top candidates is too close, the engine simply abstains. Again, restraint is a feature here, not a bug. In stage 7, the LLM is handed a small, heavily vetted shortlist and selects the single best reference. Stage 8 fetches the exact verified words via the API. Stage 9 writes a tiny, natural bridge sentence. And finally, stage 10 packages the payload for the AI interface and updates your temporal memory graph to inform future chats. The whole shebang.
Let's move to part 4 and zoom in on that hybrid retrieval and fusion step.
To make sure the chosen text perfectly fits a really nuanced human moment, Resonate does not just rely on a simple dense vector search, which, by the way, is what almost all basic RAG applications do these days. Instead, it fires off 3 independent retrievers at the exact same time. First, a TF-IDF dense vector retriever measures the deep conceptual semantic overlap. Second, because vector searches sometimes just completely miss exact phrasing, an Okapi BM25 sparse retriever hunts for exact keyword matches. And third, a specialized theme tag retriever maps a user's emotional beat directly to curated emotion labels assigned to the texts. So it's capturing semantics, exact terminology, and emotional resonance all at once.
Now, combining those 3 retrievers introduces a pretty nasty math problem. They all produce wildly different raw scores that are basically impossible to calibrate against one another. The elegant solution here is Reciprocal Rank Fusion, or RRF. RRF bypasses the magnitude of the raw scores entirely. It only looks at the position, computing a score based on the inverse of the rank. Mathematically, it just means that an item that consistently ranks near the top across semantics, keywords, and themes will organically bubble up to win.
But as they were building this out in live use, a fascinating prompt engineering problem popped up. How do you force a pastoral, deeply helpful AI to output strict JSON data instead of trying to counsel the user? The Gloo alignment layer is specifically tuned to be highly empathetic. So when it was fed emotional, first-person text, it desperately wanted to act like a pastor. It would break the pipeline by writing a warm, comforting paragraph instead of just returning the required JSON extraction.
The engineers fixed this by leveraging a really brilliant framing technique. They pinned a specific structured model and framed the prompt as third-party data to annotate rather than a message to respond to. They explicitly told the model, hey, this text is not addressed to you. By shifting the context from comfort this human to label this dataset, they completely constrained the model's behavior, turning it into a highly reliable structured data extractor.
Section 5. Let's talk about the deterministic safety gate.
All this AI orchestration is amazing, but what happens when a user is in a genuine, life-threatening crisis? Well, this is exactly why deterministic code will always beat probabilistic LLMs. Before any AI model is even called, Stage 0 runs a phrasing robust regular expression, a regex, on the raw text. It covers direct statements, passive ideation, method-specific language, slang, you name it. Think about it. An AI model can conceptually drift, or actually scratch that, it can just straight up refuse a prompt or suffer an API timeout. But a hard-coded regex, it will always execute. It instantly routes crisis language to human help resources instead of awkwardly returning a generated response.
And the evaluation harness absolutely proves this architecture works. They boast a 100% safety recall across 14 distinct crisis phrasings, with a stunning 0% false positive rate. It catches the crisis every single time without accidentally mislabeling normal text. That is massive for user safety.
Finally, Part 6, Infrastructure and Deployment. Let's see how this scales.
A theoretical architecture is great on paper, but software has to scale in the real world. The core engine here is built entirely on the Python standard library, meaning there are no heavy framework dependencies to bog it down. And by placing every external API call behind an adapter pattern, the system can run fully reproducible offline. You can use local embeddings and mock data for testing, and then flip to the live Gloo and YouVersion APIs in production with a single configuration flag. It scales horizontally using a Redis backend for temporal memory, and it can gracefully degrade to a local JSON fallback if Redis ever drops. It's incredibly robust.
And what ties all these different delivery surfaces together, whether you're using their ChatGPT extension, an MCP server inside Cursor, or a Discord bot, is what they call the Resonate key. This is a portable OAuth2 identity token that ensures your temporal memory graph actually follows you around. It passes state to manage recency, so you don't hear the exact same thing twice. It prevents theme fatigue, and it tracks narrative arcs across different sessions. Your emotional context follows you regardless of which specific AI interface you happen to be using today.
Which brings us to the end of this explainer and leaves us with a fascinating, pretty provocative question. By demanding restraint, fusing multiple retrieval methods, and strictly dividing labor to ensure anti-hallucination by construction, this architecture elegantly solves the most dangerous AI problems we face today. So if we can engineer a system to be this perfectly context-aware and structurally safe, what other vital human knowledge should we entrust to this architecture in the future? This really feels like the blueprint for how AI should handle the information that matters most.